Hi everyone, welcome to Chapter 2 Thermochemistry for SK025. In this video, we are going to talk about 2.1, Concept of Enthalpy. By the end of the lesson, you should be able to explain endothermic and exothermic reaction using the complete energy profile diagram. Then, state the standard conditions for the reactions and define enthalpy and standard enthalpy. Next, we want to define and write thermochemical equations for each enthalpy below. For formation, combustions, atomizations, neutralizations, hydrations, and solution. For energy profile diagram, first let's look at the endothermic reactions. So as we know that endothermic reaction has a positive value for its delta H, and the energy or the heat energy is being absorbed. So this delta H has a positive value, and the directions is going upwards from the reactants towards the product. So we say that the enthalpy of product is higher than the reactants, result in an increase of enthalpy of the system. As you can see in the diagram, there's a differences between the enthalpy of reactant and the enthalpy of product. Next, we want to look at exothermic reactions. As you look at the energy profile diagram, energy is released and you have a negative delta H. This delta H represents the enthalpy. So energy is released from reactants towards the product. Okay, one direction is from the reactants towards product. So going downwards indicate that energy is released. So the enthalpy of product is lower than the reactants, and this result in a decrease of the enthalpy. Alright, so next let's look at the definitions of enthalpy. So this enthalpy is actually referred to the energy and is used to quantify the heat flow into or out of a system in a constant pressure process. In short, we know this one is a heat energy. So for this enthalpy, its magnitude or the strength depends on the amount of substances present. So if you have more substance, it will have high enthalpy, and vice versa. Next, we want to look at the enthalpy change or the heat of reaction. So for the enthalpy change, we have a symbol delta H. So it refers to the difference between the enthalpy of the product with the enthalpy of the reactants. So it will use this formula. The enthalpy change or heat of reactions is the summations of product. If let's say you have two products, we need to sum up the enthalpy for product and minus the total or the sum of the enthalpy of reactant. Let's look at this standard enthalpy. For this standard enthalpy, it refers to the enthalpy change which we measure at standard conditions, in which the temperature is at 25 degrees Celsius or 298 Kelvin. And the pressure, it happens at 1 atm. And for this standard enthalpy, if we want to measure this standard enthalpy, we must specify the phases of each species, whether they are in solid, liquid, aqueous, or gas phase. So it is a must to label your phase in a chemical equation. So for this standard enthalpy, we have a symbol delta H naught. So this not refer to, it happens at standard condition. Next, we have our standard state. This 298 Kelvin 1 atm, that is the standard condition. And the standard state refers to if you have any gaseous species, this gaseous species will exist as an ideal gas at 1 atm. If you have any aqueous solution in the reaction, the concentrations will be 1.0 molar. If there's any pure substances, it will exist in the most stable state at this pressure and temperature. So this pure species, when I give you a list of example, if let's say you have oxygen gas, so at standard state, the most stable state of this oxygen gas, it appears as O2 in gas phase. H2O, this compound at its most stable state, it will exist as a liquid. Sodium Na exists as a solid atom. Carbon exists as a single carbon atom as a solid. Chlorine gas, it exists as diatomic molecule, Cl2, and the phase is a gas phase, similar as fluorine gas. And if you have bromine liquid, bromine at its most stable state, it exists as Br2 at liquid phase. And last example, here we have iodine. So at its most standard state, this iodine will exist as I2 in solid phase. Alright, so for thermochemical equations, it is a chemical equations that shows the enthalpy change delta H. So for example, here is your chemical equations, and behind solve your chemical equations, you need to write together with this enthalpy change. So for thermochemical equations, usually you will have the signs of delta H, and this sign indicate whether the reactions is endothermic or exothermic, whether the energy or the heat is absorbed or released. And we will refer to a stoichiometry ratio, which will indicate for the magnitude of this enthalpy change. For example, if you look at the first equations over here, alright, so producing 2 mole of H2O, the enthalpy equals to negative 571.6 kilojoule. But if you want to produce only 1 mole of H2O, the enthalpy will be half of it. So for example, the whole equations, you divide it by 2 to get 1 mole of H2O. Therefore, the enthalpy change, you also need to divide by 2 to get the value. Next, we want to look at the definitions of enthalpy. Remember that the definitions of enthalpy is the key for you to answer most of the questions related to thermochemistry. From chapter 2.2, 2.3 to 2.4, we need to use all these definitions of enthalpy, and you need to understand it and memorize them. So first of all, we have the enthalpy of formations using the symbol delta H with a subscript F. So this enthalpy of formations refer to the heat change when 1 mole of compound formed from its element in their most stable state at standard conditions 180 M to 98 Kelvin. So in this case, heat change refer to heat can be absorbed or released. So for example, if you want to find the compound carbon dioxide, so carbon dioxide is a compound in gas phase. So to find 1 mole of the compound which is formed from its elements, so remember elements made out of only one types of atoms. So if you focus on this CO2, we have the elements carbon. So carbon's most stable state exists as solid. And also we have oxygens, and remember that oxygens it exists as the O2 at its most stable state, and it is at gas phase. So this is the equations for formations of 1 mole of the compound. So when 1 mole of carbon dioxide is formed from its element at their most stable state, we have carbon and oxygens. Carbon solid, oxygen O2 in gas phase. So behind of it, you have your delta H, which is heat change, either positive or negative. And next, we have the enthalpy of combustions, delta H com, and this one is just the abbreviations. It refers to the heat release when 1 mole of substance completely combusted in oxygen gas. So we know that for combustion's reaction, heat is released. So that means your delta H will be negative when 1 mole of substance completely combusted. So given you one of the examples over here. So let's say if we have CH4 as our substances. So when 1 mole of the substance is completely burned in oxygen gas, and it will producing ion, and then you carry on with the equations to produce carbon dioxide and water. And then behind of it, we have a delta H, which is in negative value. So for enthalpy of combustions, our focus will be on the CH4. So this substance which is going to combust, it need to be in 1 mole. Next, we have our enthalpy of atomization. So if refer to heat absorbed, delta H is positive value when 1 mole of gaseous atom is formed from its element. So in this case, we want to focus at the product because 1 mole of gaseous atom is formed. Let's say we want to form 1 mole of sodium gaseous atom. Okay, sodium gaseous atom. It is formed from its element, and this element should be in the standard state. So standard state for sodium is solid, and behind of it we have our delta H equals to positive sign because heat is absorbed. So when 1 mole of gaseous atom is formed, it means that we need to make sure you focus on the product. So this product, it should be 1 mole. 1 mole of the gaseous atom is formed from its element. Okay, next example, if I give you, I want to form 1 mole of oxygen gaseous atom. Okay, oxygen gaseous atom. So this oxygen gas is formed from its element. So this oxygen element, it exists as O2 at gaseous state. So make sure that you focus on the product. It need to be in 1 mole. So to balance up your equation, you need to have the O2. So you balance the equation, but we focus on the product in this case. And then again, thermochemical equations, you must complete with a delta H at the end of your equation. Goes to enthalpy of neutralizations. And enthalpy of neutralizations refer to heat release, again negative sign, when 1 mole of water is formed when acid react with base. So our focus, 1 mole of water is formed. If let's say I give you the example, HCl react with sodium hydroxide to give you NaCl, aqueous solutions, and H2O liquid. And the delta H equals to negative sign. And in this case, enthalpy of neutralizations, we focus at the product water. And you need to make sure this water, you have only 1 mole. So you balance the rest of the species. And next, we have our enthalpy of hydrations. Remember about the symbol. It refers to heat release when 1 mole of gaseous ion is hydrated in aqueous solutions. So now we want to focus at gaseous ion. It needs to be in 1 mole. So next, I give you the example sodium gaseous ion. So when this gaseous sodium ion is hydrated, it becomes aqueous ion. Okay, it becomes aqueous ion. Hydrated means it's surrounded with water molecule. Heat release, again, this is negative sign. So in this case, we are focusing at the reactant. So 1 mole of gaseous ion. Gaseous ion. Okay, is hydrated. Hydrated, you are going to produce aqueous ion. The last enthalpy, we have the enthalpy of solution. It refers to heat change, can be either positive or negative, when 1 mole of a substance dissolves in solvent to form an infinite dilute solutions. So in this case, we're focusing on 1 mole of substance which dissolve in solvent. Alright, so I write the examples over here. If let's say I give you the example of substance is NaCl, solid. So when you want to find or define the enthalpy of solutions, it means that you make a solution from solid to aqueous. So NaCl, when you dissolve it, it will produce Na plus aqueous ion and Cl minus aqueous ion. And then together with the enthalpy at the back of your equations. So for this case, enthalpy of solutions, we are focusing at 1 mole of the substance. So when 1 mole of the substance dissolve to form infinite dilute solutions. Tips for you. Use all of these definitions of enthalpy to construct a balanced thermochemical equations. Again, thermochemical equation is normal chemical equations, and at the end, you need to write the enthalpy. This is an additions point for you. Standard enthalpy of formations for any elements. It is most stable state is 0 kilojoule per mole. So for example, if you got oxygens O2 at gas phase, sodium, potassium, calcium, barium, copper, they exist as a solid atom. Nitrogen gas, hydrogen gas, it appears as N2H2, F2Cl2, they are all gases phase. Bromine, most stable state is liquid. Iodine, solid. So all of these elements, the enthalpy of formation is 0 kilojoule per mole because this is how you find them. So you don't need to form them. Okay. Next, let's look at example questions number 1. Write the thermochemical equations for the following enthalpy. We have formations, combustions, atomizations, neutralization, hydrations, and solution. So first of all, formations of CH4, you have a negative enthalpy. So in this case, formation says that the heat change when 1 mole of the compound is formed from its element under standard state, under standard condition. So for formations, remember there is 2 standard. One is standard state, another is standard condition. So in this case, our focus will be at the product. So make sure this CH4 is in 1 mole. Next is the enthalpy of combustions for C2H6. Combustions release energy. And here you go. Focusing at the substance. So for combustions, heat release when 1 mole of the substance is combusted in oxygen. And then you continue the rest of the formula. So in this case, we focus at 1 mole of the substance which is being combusted. The one that Madam circle is the one that you should follow the definition. And next, we have the enthalpy of atomizations of sodium. Given here is the heat absorbed, positive sign. So the heat absorbed when 1 mole of the gaseous atom is formed from its element. So in this case, our focus will be the product when 1 mole of the gaseous ion is formed. So here's our focus. And number 4, D, enthalpy of atomizations for F2, again, heat absorbed. So heat absorbed when 1 mole of the gaseous ion is formed from its element, and this element should always be in standard state. Alright, so we need to focus at the product when 1 mole of the gaseous atom is formed. Enthalpy of neutralizations of reactions between HCl and NaOH. So for enthalpy of neutralization, make sure that you only have 1 mole of H2O is formed. You need to keep this one as 1 mole. And for F, enthalpy of hydrations for K plus, negative 320 kilojoule per mole. Alright, so 1 mole of the gaseous atom is hydrated. Keep this K plus gaseous ion 1 mole. And lastly, we have our enthalpy of solutions of NaCl. When 1 mole of the substance dissolves to form infinite dilute solutions. So it will producing aqueous ion, Na plus, Cl minus. And at the end, we have the enthalpy. Okay, heat change can be positive or negative.
So that's the end of our chapter 2.1. Please attempt the exercises and try to understand and memorize all the definitions. We are going to use it for the following subtopics. Thank you.